Before I talk about the example I have in mind for these computations, I do want to mention that usually when I'm talking about the standard deviation, I'll abbreviate it StatDev. Sometimes you see it abbreviated STDev or STDV. There's a few different ways you talk about it. I generally go with StatDev, but just bear these formulas in the back of your mind. And if you want to think about this stuff in the context of those batteries from earlier, what we can do is run these computations where, like I said, I recommend running them in the calculator rather than by hand, not least of which because the calculator will give you some other useful information along the way. But long and short of it is here that using the calculator, we will get standard deviations of sigma B1 for the first battery of 6.8 hours, while for the second battery, we will get a standard deviation of 2.6 hours, showing that, again, the second battery is more consistent. Where here we're saying that, on average, you're only off by about 2.5 hours, whereas, on average, you can be almost 7 hours away from the mean when talking about that first battery. Kind of confirming our suspicions that we started with, but it is nice to have that numerical, clean way to actually see it. And that's what these measures of variation really are for. And we're going to finish this section first with a little bit on estimation and a little bit more computation we can do with this stuff, and then some special rules that fall out from these constructions and that lead towards things we're going to be seeing later on in the semester.